We're over here. The mic is on. Yep. Light's green. Cool. Okay. Well, hi everyone. Welcome to the. Did Pavel want to do some sort of greet, or Matt? Did Matt want to do some sort of downstairs greeting? Well, when he shows up, we will get him to do a welcome after the facts. But I'll keep it brief. My name is Murph. I am Principal Solutions Engineer for Upbound. I lead our field engineering team for EMEA and the East Coast of the United States. And I'm also a contributor to the Crossplane project, which is what we're going to be talking about first. So the Crossplane is a CNCF project that is aimed at answering the question, what if Kubernetes, but for everything else? And I'll dig into that a bit. But the idea is to allow anybody to build a control plane for their infrastructure. This concept has been around forever. The cloud services providers are building their own control planes for their own offerings. What Crossplane does is it allows you as a platform engineering group to build your own control planes with your own opinions and for your own stuff, and to bring a bunch of different things together and expose out a bespoke API that reflects your opinions on how things should work based on the Kubernetes resource model and using the tried and true Kubernetes API machinery under the covers. So, like I said, it's part of the CNCF. It was launched back in 2018. I just saw Matt walk by. Launched back in 2018 by the creators of Rook, and is now an incubating project within the CNCF. We're aiming for graduation next year, we believe. There's a pretty healthy community grown up around it, and then most of the maintainers who were founding members are still employed at Upbound, which is the sort of the corporate sponsor at this point of the project. But we have contributors from AWS, from Azure, from lots of our customers, as well as users of the technology who aren't customers, all across the spectrum of sort of technology ranges. Most recently, we released 1.14. I personally have been with Upbound and been working on the project for a little less than a year now. This is the biggest release we've done yet. So the project releases quarterly, but 1.14 is fantastic. And we're going to talk about some of the features that came with that today, as well as just a general overview of what's going on. We'd love these numbers to be higher. Right? These are great community numbers for a CNCF project. We're not at the top of the list, but we're not at the bottom either. But there's a call to action at the end to get you guys to contribute. But I'll put one here at the front as well. Please join the community. Join us on Slack. It's a great environment. There's lots of things for you to work on, as well as lots of help if you need it. So the basics. How does Crossplane actually accomplish the stated goals? So the first fundamental construct is a managed resource. So a managed resource is a one-to-one representation of the underlying external API as a Kubernetes object. So we're going to be using the example of AWS as an external API, but this can be anything with an API that you can drive. The big three cloud providers are sort of at the top of the list, but you can also wrap a Terraform workspace. You can talk to your networking infrastructure. Aviatrix. I always have to look at you when I say Aviatrix. Sorry, because I always want to say something else. I can never remember the name of the company. So Aviatrix for networking infrastructure has a provider, and there's just a whole ecosystem out there. And so anything that has an API can be a managed resource within the Crossplane environment. This is what one looks like. So for an S3 bucket, for example, you have your version, kind, all your usual Kubernetes constructs, and this information then gets passed on into the external API call in order to create these managed resources as you go. Your spec contains your desired state. Your status contains your observed state, and every reconciliation loop of that object will compare those and then ensure that the infrastructure is in the desired state according to the object that you have defined. They generate Kubernetes events out. So if you want to monitor your infrastructure and how it's going, whether it's drifting and what the provisioning status of that, you do that using your traditional Kubernetes observability, monitoring metrics capabilities, all of that. The API machinery is just the same, and running within it, the provider operates as a Kubernetes controller that is going to translate those things into the external environment. With me so far? Yeah. So far, so simple. Importantly, before I asked earlier, does anyone already know Crossplane? I am assuming everybody knows Kubernetes. It's in the name of the meetup, but is there anybody for whom I'm just making way too many assumptions? Okay. Importantly, the Crossplane runtime is just an extension to the Kubernetes API server. So all of these capabilities are just tied directly into your core machinery. Right. So the controller runtime is at the heart of the providers, which are doing managed resource reconciliation, things like exponential backoff, polling intervals, role-based access control, auditing, logging, all of that is all the same that you would have within any other Kubernetes environment. And indeed, you can turn any Kubernetes cluster into a cross-plane control plane. I'm going to start using the term control plane a fair amount. When I say capital C, capital P control plane, what I mean is a cross-plane control plane, not a Kubernetes control plane or an anything else control plane, but a universal control plane as realized by Crossplane and your input. So building your control plane, right? Because if all we did was translate external APIs into Kubernetes objects, would just be a set of operators, or the KCC project, ASO, the ACK, right? The Amazon controllers for Kubernetes. All of those do the exact same thing. They translate an external API into objects within Kubernetes land. So we'd be good at it, but we wouldn't exactly be a different project. And what would the point be? So where Crossplane takes it to literally to the next level is in the concept of compositions. So you're able to compose together these managed resources into your own platform API. And you design the interface that end users are going to experience based off of the assemblage of these capabilities. Importantly, the design and delivery of this API, the composition of these managed resources is all done with Kubernetes objects, composite resource definitions and compositions, and all the machinery, they are themselves declaratively constructed via other Kubernetes objects. So controlling who's able to author APIs, controlling what those APIs should look like, should contain, that can all be done with standard Kubernetes projects, things like OPA and Kyverno for policy administration. You are not allowed to create a composition of AWS buckets unless they have these things. You can't create a bucket composition without an encryption policy. You can't create a bucket composition without a bucket policy that has this shape. And you can enforce that using Kubernetes controls. So any project that can operate on a Kubernetes API can operate on your platform API. So we talked a little bit about managed resources. Those are the little green elements, the building blocks. Those are delivered by providers. The middle tier, configurations, is the packaging for your composition. And this is where the lingo starts to get off the rails a little bit, so stay with me. Composite resource definitions are the XML, the YAML rather, sorry. I just transported myself 20 years back in time and got very scared. Yeah, oh God. The S stands for simple. So the composite resource definitions are a bit of YAML that define the shape of your API. And then the composition you can think of as the code behind or the implementation of that API. And you can have multiple different compositions for a single composite resource type, right? So if we think of this as in more concrete terms, I want to expose Postgres as a service, as an API to my users. The end user is going to claim a small Postgres instance, and so their YAML, that small Postgres, is going to just go into their workload environment. That will conform to the composite resource definition, and then you'll have an AWS composition that implements Postgres. You could also have an Azure composition or a GCP composition that implements Postgres and ties together the things that you need in the back end: security groups, network access, the database itself, etc. This is what they actually look like. So the composite resource definition has an API group and a kind and a standard open API schema. Excuse me, goodness. There are lots of tools that allow you to generate open API structural schemas. By the time you've chosen one, you will already know enough about writing it in YAML that you'll just write the rest of them in YAML. The first thing everyone who works at Upbound, every engineer who comes to Upbound, the first thing they try to do is improve this process. And by the time they're done, they realize that any tool that is able to generate open API schemas is a proper superset of the open API schema. Either that or it's making simplifying assumptions and it doesn't actually allow you to generate full schemas. So just use the YAML. Get over the learning curve. It's a little painful at first, but at the end of the day, you just write in YAML and it's great. Use VS Code snippets, solves everything. The composition is similarly an object definition that then ties to that API ref. You'll see that middle block there. That's where we're referencing the API type that we're implementing. All right. And then you have a list of managed resources, the things that go together. Now, if it were just a simple list, that wouldn't do us a whole lot of good. We need to be able to tie them together, take in parameters from the calling API, and do some work with them. Right. So we have a notion called patch and transform, which allows you to go through that managed resource list and map from simple values into composition-specific values, like EU actually means EU North 1 or North Europe if we're running in Azure, right? So you're able to make sure that API is human readable, but then implemented correctly on the back end. And you're able to patch from one managed resource into another. Maybe you need the VPC ID in the subnet declaration. You need the bucket name within the bucket policy, etc. So patching allows you to connect those resources together into the implementation behind the scenes. So for extending Crossplane, because this is all good so far, but we need to be able to add new capabilities to the platform. There's essentially 3 extension points, 3 package types. Used to only be 2, but as of 1.14, now we have 3, and we'll talk a lot about functions in a minute. But providers, this is your connection to your external API. Creates a one-to-one representation with the managed resources of the external API, the building blocks of your platform. Configurations are the containers for all those different composite resource types and the compositions behind them. And then functions allow you to implement additional composition logic in the language of your choice, using whatever tool you want. Now, most of the first generation of them are written in Go. Nick Cope, who's sort of the lead engineer on this capability, he's building out a Python SDK. We've talked about a Java SDK. We've talked about expanding it out. Right now, the only official SDK is in Go, but that's going to change very soon. 1.14 released 2 weeks ago. So we're still very early in this. And so you end up with an ecosystem of providers. We've got, as I mentioned before, the big 3 cloud services. We have one for Terraform. Basically, if it has an API, it can have a provider. And importantly, we also have the ability to generate providers off of Terraform providers. So there's a project called UpJet, which is a code generation framework. If you point it at a Terraform provider, it will generate a Crossplane provider based off of that code base, which is an incredibly powerful way to get started quickly, whether it's a custom provider that you wrote internally, or if it's a provider for a more esoteric piece of infrastructure that just hasn't made it into the Crossplane ecosystem yet. Great way to get started quickly. And then if you need to, you can migrate into native code in order to take advantage of better performance or other features that aren't present within the Terraform provider. You can find all of these in the Upbound marketplace. Excuse me. This is a clearinghouse for all the providers, not just ones built and maintained by Upbound, but any community providers can be found there, as well as sets of contributed compositions that have sort of standard use cases. We've got clusters as a service, databases as a service. There's a handful of those. Ultimately, those are mostly useful as just ideas for getting started. The whole point of Crossplane is you're building your opinions into an API. And so starting from someone else's opinions is a great way to get started, but you're always going to end up with your own at the end of the day. Some of the new stuff in 1.14, and I'll highlight this quickly, and then we're going to move on to the next fun bit. Deletion ordering in Kubernetes is bad. Kubernetes eventual consistency model is great for creating things, right? Eventually they'll be fine, but deleting them doesn't always work out, especially when there's interrelationships between the different pieces of infrastructure. The sort of classic example from Crossplane land is, let's say I create an API to allow new workload clusters to be deployed into a piece of infrastructure. I'm going to spin up a new Kubernetes cluster. I'm going to load into it some standard infrastructure via Helm charts. Those Helm charts might then themselves create other things. Let's say an application load balancer. All right, so I deploy an EKS cluster. I deploy a Helm chart into that is going to create application load balancers. If I delete the EKS cluster first, that application load balancer will never be cleaned up, right? And Crossplane doesn't know about the ALB because it's managed by a resource that it knows about the resource, but it doesn't know what the resource has done. So we need to create an ordered relationship, a dependency relationship between those objects in order to ensure things come down in the right order. And so the usage API allows you to do that within 1.14. So the usage type allows you to say this object is using that object. That's it. That's all it does. And it won't allow you to delete the one object until the other is gone. Owner references were sort of Kubernetes' native way to handle this, but you can't have more than one owner. And those relationships are within the context of Crossplane don't always make sense. It's not really an owner relationship. It's more of a usage relationship. So the usage type was born. An interesting use case, though, is you can now create a usage with no buy clause. I was blanking on the clause. So you can just say, this is used, and it'll never be deleted. Crossplane will never delete it. Importantly, Crossplane won't delete anything unless you ask it to anyway. One of the challenges with other IAC tools is that sometimes they delete things when you didn't really want them to, because you changed a name or something, and you're not allowed to change that field. But the IAC tool says, I'll change it for you. I will change it right now. Crossplane won't do that. One of the nice things about using the Kubernetes resource model is you also get the Kubernetes operational intent. So the only way a managed resource gets deleted is if you issue a delete command into the API machinery. This has the knock-on effect of, well, maybe I wanted to delete and recreate the thing, and now I have to actually do that. But we think that's safer than accidentally blowing things away. And this takes it one step further. Even if I were to issue a delete command against that RDS database, won't happen. Just won't happen until the usage has been cleared. Yep. There we go. Functions. Right now, compositions, the patch and transform mechanism has no iteration, no conditionals, not really even any templating. It has a little bit in the way of string templating, but that's not intended for big templating capabilities. No advanced logic at all, other than simple patch and transform. The list of resources is static, and you can't really get information from outside. Everything that's going to be part of the patch and transformation has to come in through the API that you design. Now, there are mechanisms like environment configs and other things that you can sort of back channel information into the system, but ultimately, it was just largely inflexible, which covered 80–90% of use cases. But there's always going to be a use case where you need to be able to do more. And we didn't want to grow our own DSL in YAML. That's been done. It's terrible. So instead, what functions do, so first released in alpha back in January, December, evolved a lot. So if you tried composition functions, if you have seen Crossplane and you tried them back at the beginning of the year, forget everything you know. We evolved the API and the internals quite a lot. And the beta is just fantastic. So launched as beta within 1.14, it allows you to inject complex logic into your composition pipeline, and you can do some really cool stuff. In fact, Jeff is going to show a use case of that with the service binding capabilities. Essentially, they're packaged up as OCI images, just like providers and configurations. And internally, it's just a gRPC call. So that a function is just something that conforms to a particular gRPC spec. So it can be implemented in any language. If it talks gRPC and if it can speak this API, then it's ready to go. And so you create a whole pipeline of functions, and Crossplane will call out to each of them, and then they will, depending on the nature of the function, you can do simple small transformations, or you can create an entirely new set of managed resources based off of inputs. One of our examples for getting started is taking a list of database names and creating new RDS instances for each of those. So the input is just a list of names, and the output is a whole slew of managed resources that provide that capability. Importantly, not everyone needs to write their own functions, right? So there's a lot of functions already. We had a Contrib Fest at KubeCon last week where we're trying to get people to write more very general purpose functions. If you have a great idea for a general purpose function, jump in the Slack, go into Crossplane Contrib in GitHub, and submit it there. But as this grows, you're going to need fewer and fewer of these to be custom, and you're just going to be able to reuse the capabilities that are out there. Basically, you can remix any capabilities alongside the functions. So that's all I wanted to show. There's a link here in the demo. I think, Matt, we're gonna put these slides up on the meetup afterwards, right? Yeah. So you'll be able to follow this link at that time. Right. We'll put them somewhere. You can follow the demo if you're interested. I said at the top, there's going to be another call to action at the end. Get involved, please. We love additional contributors, even if it's something small. My most recent contribution to the project was adding return nil to the end of a function, and that's it. So that it needed done because it was missing, and so the logic was falling through into a block of code it shouldn't run. So even a small contribution is always welcome. And here's if you're already using Crossplane, share your story in the adopters file within the project. Any quick questions around Crossplane itself before we show things you can do with it. Yeah.
Question.
Yeah.
OpenTofu, the open source version of Terraform.
Sure. Yeah.
Is that Terraform capability going to be able to be one-to-one across?
That's a good question. The answer right now is I don't know. Right. So we are keeping an eye on the OpenTofu project. We are, as many people are, kind of surprised by some of the changes in Terraform. We weren't expecting them any more than anybody else was. So as demand for the use of OpenTofu grows, I think we'll probably see that accommodated within Crossplane. There's currently, the way Terraform is used in different contexts within Crossplane will probably require different things with regards to tofu, right? So the provider Terraform probably will not suddenly become provider OpenTofu. There will be another provider for OpenTofu. There will always be a Terraform provider, and there will always be an OpenTofu provider. Similarly, the use of Terraform in Upjet, for example, actually doesn't use the Terraform CLI anymore. It did, but we were already on a pathway to remove that and to have the code generation talk directly to the upstream Terraform providers. Those are still perfectly open source and maintained by whoever they're maintained by. That whole ecosystem is its own ecosystem and not affected by the BSL change in general. There's a couple, but in general, not affected by the BSL change. So we don't actually see a need to change that either, unless we see that ecosystem go away and a whole second ecosystem crop up, which seems unlikely to me. So I know that's not a great answer to your question, but we are definitely keeping an eye on it. And I think that I would expect to see the use of OpenTofu grow within Crossplane as it grows within the community. Yeah. So that's sort of where we are now. Could change tomorrow, right? It's a pretty dynamic sort of environment. Yeah. Do you have a question? Yeah. 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 Yes. Well, the Argo CD provider has a, I think it's got a kind that allows you to create Argo CD instances. Yeah. So that if you can connect to the Argo CD. Yeah, so you can do both, right? So ultimately, so there's a, I wanted to put a plug in here. So I had a talk last week at KubeCon called Introducing the Backstage Argo Crossplane in Kyverno. That was myself and Ritesh Patel from Nirmata, which is the company behind Kyverno. And then we also had inputs from Nick from Acuity, which is the company behind Argo CD. And so, and unfortunately, I was the guy who figured out how to put Backstage into the demo, which is, if you knew me better, then you would know that's a hilarious joke. But it worked out, which speaks to the flexibility, I think, of Backstage, if I could figure it out. But what we're doing in that demo is actually spinning up the whole backstack using Crossplane as the root. So you start off with a Kubernetes cluster, load Crossplane into it, and then I've defined an API that I just called a hub, the backstack hub, and you create an instance of that kind. So composite resource definition called hub. The composition uses our Helm provider to load in Cert Manager, Argo CD, Vault, Kyverno, a couple other bits using the Helm provider and also the Kubernetes provider, which allows you to create arbitrary objects within any Kubernetes cluster. So that's one way to do it. Use Crossplane as sort of the infrastructure provisioner. And then importantly, the use case in that demo is a hub and spoke architecture for Kubernetes clusters as a service. So the other type that's exposed there, so you have a hub type, and then you also have a cluster type. And that cluster type can either be AKS or EKS, so either Azure or Amazon. And when you create a new Kubernetes cluster, the composition for that will register it into the Argo instance that was spun up in the hub. So it copies over the kube config and it manipulate. It actually uses Kyverno to manipulate that, because for whatever reason, Argo CD can't read a kube config. You have to mangle it into this other format. And Kyverno is really good at doing that. So Kyverno can read the secret and transform it, and you're off to the races. And so you're now able to go around that loop again. So create a cluster, register it into Argo, see it within the Backstage catalog, and then you can scaffold an application workload, which will target that cluster that's registered within Argo and within Backstage. You go around again. You say, all right, create me a Git repo that's going to provision via Argo into that workload cluster. And maybe it will ask for an S3 bucket or an RDS instance alongside that same Helm chart. And Crossplane will kick in and say, okay, let me go deploy your. So all of these technologies really can mesh together really well. And since they're all talking API server, they're all talking kube config, they're all using the same machinery underneath, it takes very little effort. 80% of my time building that demo was figuring out Backstage. And 90% of the remaining time was spent writing a bash script so that I can install the whole demo with a single line. Because anyone who's ever tried to wrap their demo in a bash script knows that's the worst idea on the planet. So very little of my time was actually spent getting the tools working, and I built the hub API in no time at all. I borrowed the cluster API from our cluster as a service use case, but I tweaked it a little bit in order to fit the demo situation and the requirements of. So I approached it as a platform engineer. The requirements of my platform are deliver these 4 components into a Kubernetes cluster, deliver a cluster API as a service, right, and tie them together. And so I was able to adapt the existing materials, the existing tools into my platform deliverable very quickly. It was a lot of fun. Yes. So I was meant to check earlier. I'll check while Jeff is talking, and we can add some links at the end. Yeah.
So following on from that question.
Yeah.
For example, describing a infrastructure cluster and a deployment. Is that a standard topology that you're seeing?
Yeah. So you'll end up with control planes of control planes usually. There's never one control plane to rule them all. And when I say control plane, I mean cross-plane control plane.
We completely steamrolled past you. I didn't know whether you wanted to do any remarks or. Okay. All right, we got everyone back.
Everyone who matters.
Be a test for the people walking late. All right, so my name is Jeff Ellin. I'm a solution architect at VMware. I work on their Kubernetes team, everything related to VMware Tanzu. What I'm going to show you today is a piece of technology that isn't directly related to Crossplane, but it is kind of tangentially can be useful with a Crossplane implementation. And it's actually a piece of functionality we deliver in part of our commercial Tanzu product. But everything you're going to see here today is all open source CNCF stuff. You can go and replicate this at home using open source. So my background, although I'm spending a lot of time these days talking about Kubernetes, is I am an application developer by training, by career. I do a lot of software development, so thereby what I tend to get involved with is less on the infrastructure side of Kubernetes, but more on the developer enablement side of things. Like, how do you make developers more productive? How do you make their lives easier? And how you can, as a platform operator, help out your developers. So what we're going to talk about today is the Kubernetes service binding specification. This specification it's based on a concept. If you've ever worked with either Cloud Foundry or Heroku, the concept of binding a service to an application. So as an application developer, I have this application that needs a database. I want to bind that database to the application that's going to be consuming it, or applications that are going to be consuming it. I need a way to hand over information about where the database is, what its host name is, its port number, database. It may keep doing that. We'll see. It's not plugged in. That's the problem. I'm using the plug over there. No, it's plugged into the other laptop. Yeah, see. Yeah. So anyway, what the Kubernetes binding service binding specification does is it allows you to declaratively say, as an application developer, I need to connect to a database. You identify that database by name, and then that database, no matter what environment you're running in, whether it's your production environment, your QA environment, your test or development environment, the application is then able to request access to that database. Its credentials are passed automatically to the application. Developer doesn't necessarily need to worry about how to connect to the service that's going to be helping their application out. In the Cloud Foundry world, if you've ever worked with Cloud Foundry, there was a command line utility where you could do, as a developer, you could do CF create service, database, PostgreSQL, give it a plan name, size, small, medium, large. It would go off and create a database for you. And then you would do something called bind service, CF bind service, the name of the service and the name of the application. Those two are now paired together. Whenever the application starts up, it's going to consume the credentials automatically through the service binding. One of the things you might notice is that, although this is kind of a new specification, it's been around for a while. Because if you think back to how long Heroku's been around, Cloud Foundry's been around, it's been around for quite some time. So the service binding specification is an attempt to bring the same level of functionality to Kubernetes. So normally in Kubernetes, you would configure things like secrets. You might have a bespoke, customized method for your team for consuming application resources. So what the specification does is help you, normalize that into a standard. So a Kubernetes-wide specification allows the developers to focus on business value rather than, writing utility code on how to retrieve secrets and how to work with secrets, things of that nature. And again, lineage dates back from Cloud Foundry and Heroku. So there's a couple different roles within the the Kubernetes service specification. There's the application developer that wants to be able to get the credentials they need consistently and predictably. We're going to cover a couple other roles after that, and then I'm going to do a demo to show you how this all can work with Crossplane. So as a developer, I need a cloud agnostic way to consume credentials, not only to consume credentials, but actually potentially even to provision the resource itself. Crossplane has this concept of a claim. Developer creates a claim on a resource. Crossplane goes and then contributes and creates that resource. But we need a way to pass back information back to the application on how to actually utilize that resource. We do this through something called workload projection. Again, this is a way to standardize and formalize a way to do something you're probably already doing today, but it's standardized. So you don't have to reinvent the wheel. What this is an example of the service binding root. That's basically a directory structure, standard environment variable called service binding root. Underneath that, you have directory structure, the name of the service, and then a standard set of fields for the credentials. So you can have a type, a provider, a URI, username, password, etc. The values here, we'll talk about what these values are because they are standardized into what we call well-known values or well-known fields. So applications can consume those directly. In terms of this consumption, a lot of different programming languages can be used to do this. We've got, most of the popular ones covered: .NET, Java, Go, Spring, which is part of the VMware ecosystem, actually does a really great job of this because the application actually doesn't need to do any configuration to consume a service binding. Here's an example written in Java. It's very kind of simplistic code, but basically you're getting the service bindings that are available. You're finding the one that you're looking for by name. And then from there, you can start to pull out the information that you need, like the URL and the connection string. As the service provider, I need to be able to have a consistent way of provisioning resources and providing secrets back to the user that is trying to claim them. So the way we do this in Crossplane, and Murph talked a little bit about this, is with what we call a composite resource. So composite resource is a definition that defines what exactly I need to claim. So this is actually not a composite resource, it's actually a claim, but it says that I want a database. I maybe push in some fields like I need it to be a small database with a certain amount of storage or certain configuration details. And then rather than relying on the developer to need to know all the knobs and lists and buttons to configure a database, they really just need to know, a menu, small, medium, large. In addition, you can provide this as a standard way of doing that. The only thing that is required in order to be, quote unquote, a service, bindable service, is it has to have this field called status binding name. So that's not a field that Crossplane normally populates. However, using a composition function or using the patch functionality within Crossplane, we're able to pull back the secrets that we need, populate them in a secret, put a populate a field with the name of the secret that contains the information for connecting to the resource. So that's the most important part. As long as it's got status binding name, then it's what we call a bindable resource. The secret that Crossplane produces, this is just an example in plain text. Got some fields in it that we saw earlier. We got type, provider, host, port, username, and password. Those are our standard fields. There's a list of what we call well-known fields, and I'll show you that in a second. But essentially, as long as your secret kind of looks like this, you're good. And again, there's functionality that Murph didn't talk about in Crossplane about how secrets are returned back from a provider to the claim that was used to produce the resource. But basically, and I'll show you an example of this in the code. But at the end of the day, we're producing a secret that looks like this. A couple fields in there, and the field names are standardized. So you always want to put a DNS resolvable host name or IP address in the field called host. You always want to put a port, URI, username, password, certificates, etc., in the appropriate fields. You can add additional fields, but these are kind of like the reserved list of fields that you want to populate if you want third-party libraries to work correctly. So for instance, when I show you the Spring Cloud bindings functionality, it expects that host contains the IP address or the host name to connect to. It expects port to have a valid port number, etc. As the application operator, I want to be able to have a secure way to transfer these secrets to workloads or deployments, if you will, in a secure and consistent manner. The application operators, what they'll do is they'll bind the application to the resource. So if you remember back, I said in the Cloud Foundry days, we used to run a command called CF bind service, give it the name of the application, give it the name of the service. This is very similar. We have a Kubernetes object called service binding. You have the name of the service that you want to bind to, and you have the name of the workload you want to bind to. Pretty simple. So this is the way you connect the two together. There are some options that you can do for the service name. You could bind by a label. You could bind by a couple different options there. And for workload, you can do the same thing. And that allows you to actually use the same resource for more than one deployment. So you could say, I think I got an example here. Selector for the workload is everywhere where the deployment has these labels. So that way you can have the same data store mapped to multiple resources. So this is the binding part of the service binding specification. This resource here, service binding, that's implemented by the service binding specification. There's a reference implementation of the service binding specification available at servicebinding.io. However, there are tools, for instance, the VMware Tanzu application platform also happens to implement the service binding specification. For further info, I'll leave this up there for a second, but we are going to distribute the slides. Very quick demo is the next thing coming up. And if there's any questions at the moment, while I get the slide over here to do. Binding.io. However, there are tools, for instance, the VMware Tanzu application platform also happens to implement the service binding specification. For further info, I'll leave this up there for a second, but we are going to distribute the slides. Very quick demo is the next thing coming up. And if there's any questions at the moment while I get a slide over here to do the demo, anything at the moment? All right, so what I wanted to show you guys is a couple things. One is actually a real life implementation of a composite resource. I, as a platform operator, this is my persona, want to expose a database to developers that may want to consume those databases. I actually want to do that through Crossplane. So I create a composite resource definition, which describes the schema or the fields that are going to be in the CRD that the developers can use to claim the resources. So this is the composite resource definition. You see things like the open API schema. It has a couple fields. It has a specification, things like a database name and enable persistence. Very simplistic. I'm not giving the developer too many options. I'm just saying, what is the name of the schema that you want me to create? And do you want me to use disk or not for this database? If you're writing a development system, maybe you don't want to persist the application to a PVC. On the claim side, the developer who wants to implement this service, they can claim the database using the custom resource. So I'm calling it my Helmish data store only because I'm using Helm to provision it, but you can use other types of application, whether it's I've got an example down here of RDS as well. The nice thing about this is that you can have multiple implementations for that interface. So you can have a Helm version of it, an RDS version of it, and the developer doesn't necessarily need to care too much. They're just going to ask for a database. So maybe in the production environments, you're actually provisioning RDS, but in your lower environments, you're using Helm charts that are just running on the Kubernetes cluster. So this is what the developer will use to claim that resource. And then the interesting thing here is the composition. This is a real life kind of implementation of a composition. What it does is it actually creates a single resource. You could create multiple resources, but I'm just here is using it to create one resource. I've got a release. Release is the object that we're going to create, or we're going to have Crossplane create the managed resource. A release is essentially a Helm chart, deployment of a Helm chart. So you have the things that you would normally expect when you want to deploy a Helm chart. You've got the values that you want to overwrite. You have the namespace you want the deployment to go to. You have the name of the chart and the repository that the chart is located in. And then you also notice I have some fields called TBD. The reason why these are TBD is that they're not known. The value of those are not known at the time that this CRD is applied to the cluster. It's only known at the time that the resource is created and claimed. Connection details here essentially collects information from the resource that's created by Helm and stores it in a secret that we can consume. Now, as you can see here, the secret that the Helm chart for Postgres creates contains a couple of values. It contains a data field called Postgres password. In the service that it provisions, it's got a port number, and it also has the IP address that the application is going to be listening on. So we're basically reading data out of resources that were created by the Helm chart. The reason why we don't know the name ahead of time is because Helm, the release infrastructure within Crossplane, actually adds a field to the end of the name. So it's like, in this case, I've got a release called, actually, I don't have a name field here, but it'd be the name of your resource. Actually, yeah, there's no name here. I think it's actually in a patch further down, but it's going to be the name of the resource dash some random string to differentiate it. So what we can do is I actually pull that information out in my patch. So I've got for instance, here I've got an example of that. The from composite field. Nope, that's not the one. yeah, so all these names I think are filled in here. So spec.connection details, the name of the chart that gets deployed happens to be in a label called chart full name. I'm just grabbing that chart full name from the resource that's created and then substituting into spec.connection details first in array.name. So connection details first in the array dot name gets replaced automatically with the value that's in this label down here, chart full name. So that is the way we provision the resource. You'll also notice there is another transformation here that writes the value of the secret or the name of the secret to status binding name. Remember, we needed status binding name to be what we would call a claimable resource. So at the end of the day, when I claim that resource, that's where I'm going to get the information I need to claim it. So I actually have, I know that's probably kind of small. How's that? People read that okay? So I am going to go into, let's just make sure that I am clean, meaning I don't have any of this stuff already. So none of this stuff exists. If I go to releases, there's no releases. Okay. So I'm going to do kubectl apply minus f my claim. And then I'm going to go back to K9s and we can see that a release has actually just been created. This is a Helm deployment. If I go into pods, you can see that it's just spun up a Postgres database using the Helm chart. And then our connection details are written to a secret. It's actually in other namespace. It's this one here. We've got the name of the database that I asked for, the host name of the database, the password to connect to. There's no releases. Okay. So I'm going to do kubectl apply minus f my claim. And then I'm going to go back to K9s and we can see that a release has actually just been created. This is a Helm deployment. If I go into pods, you can see that it's just spun up a Postgres database using the Helm chart. And then our connection details are written to a secret. It's actually in other namespace. It's this one here. We've got the name of the database that I asked for, the host name of the database, the password to connect to, port, type of database, and the username. Now that I've got that created, I can actually see an application running that is going to consume that database. So quit out of here. In this directory here, I'll post a link to GitHub if you guys want to see this, but in this directory here, there are a couple things. First is the service binding implement installation itself. It's just this is just the YAML that I grabbed off of the service binding IO website. And then what I need to do is I need to bind that application to a workload. So I'm going to go ahead and apply this YAML here. So this is kubectl apply minus f workload binding. And then I can do kubectl get service bind. It's actually service bindings -a. And you'll see that the service binding has found a secret that satisfies its needs. No workload is found because I haven't actually created the deployment yet. So in my deployment here in workload, it's just a Spring application that's written in Spring Boot. It's a reference application you can download called Spring Pet Clinic. And the Pet Clinic application essentially allows you to specify an environment variable that tells it what kind of database you want to use. So whether you want to connect to MySQL or Postgres or H2, I'm telling it that I want to use Postgres. But nowhere in this configuration have I told it where Postgres actually lives. So what I'm going to do is I'm going to do kubectl apply minus f my workload. Oops. Now if I get the service bindings, you'll see that the service is now bound to an application. And I can see that, I can actually prove that by looking at the application itself. This is the one right here. I'm going to just shell into it using K9s and go to cd/bindings. Remember, this is that service binding root, this well-known location. I have the name of the binding, and then I have the fields that contain the information that I need. Now, on the Spring side of the application, the Spring, because it is aware of service bindings and it sees that environment variable has been set, it automatically prefers credentials that are in the service binding over anything that's configured locally in the container. So if I actually look at my log file here, I mean, it starts up just fine. It says that Tomcat started. It's running in the Postgres configuration. And at this point, the application is, ready to go, consuming its resources from Postgres. If for some reason that I wanted to change this from a Helm chart implementation of Postgres, I could just swap out the composition. For instance, I have an RDS version of the composition here. It actually provisions what in the RDS or Amazon provider calls an instance. And then I'm providing a lot of configuration here, but my inputs, what I'm asking the developer for, are the same, whether you want to persist to disk or whether you want, and what you want the name of the schema to be. So the developer actually doesn't actually need to worry about how things are implemented in the back end, as long as they're able to bind that application to the service, they'll get that all automatic. Obviously there's some edge cases you got to think about, such as like where you want the name secrets to be published, what namespace, what RBAC you want to use, and that kind of thing. But once you get that set up, developer claims a resource in a particular namespace, the credential would be delivered to that namespace unless you need it somewhere else, obviously. And then you can use RBAC to protect that secret. Any questions? Sure.
The last thing on what part of it?
All of it's available outside the community. Current version of Spring Boot with Spring Cloud plugins support this. You can do the service binding implementation using the reference implementation from servicebinding.io. And then obviously Crossplane itself is also CNCF. The implementation as part of Tanzu is a little bit different, a little bit more functionality, but everything I showed you today can be done using the open source tooling. Yeah. Right. And fortunately, you can do one of two things. You can just hand the credentials as a secret to somebody, but it's even more useful if the developer who's writing an application just can use a library to consume those secrets and don't necessarily need to know how they were produced. Sure.
Look at solutions that might have sidecar running within the same pod, is that finding work and then take this available to.
So there are tools like HashiCorp Vault has the sidecar implementation. This technology is meant to kind of avoid that setup. It's meant to create a resource that is bindable and then has the connection information stored in a secret. Now, obviously, if you're using a service like Vault to store your secrets in, Crossplane has the ability to publish the secrets to Vault. You'd probably be looking at a standard, library to communicate with Vault for the application rather than using the specification. All right.